In our daily lives, we perceive the world as simple and understandable. If we drop an object, it will fall. If we kick a ball, it will travel a certain distance. If we turn off the light, the room instantly plunges into darkness. Everything follows the law of cause and effect. We think that all processes in the universe work logically and that everything can be explained, but this only applies to the world we see. When we go deeper into the realm of atoms and particles, this simple logic begins to break down. In the quantum world, the rules change. Electrons can exist in multiple places at once, and taking a measurement can alter the outcome. Light sometimes behaves like a wave, sometimes like a particle. This is why quantum physics is not only difficult but also deeply puzzling. Even the greatest scientists in the field have been stumped by certain questions. The problem here is not in the calculations, it's in understanding. This video will take you into those very mysteries. We'll explore a quantum paradox that challenges the human mind and upends our perception of reality. If you take just a couple of seconds to subscribe to the channel and like the video, I'd really appreciate it. Now, let's get started. Now, let's take a moment to put aside the world we think we know and look into a completely different realm, the quantum world. In this realm, things don't behave the way we're used to. There is no fully solid or completely stable reality here. This is what we call the quantum world. In this realm, electrons behave in strange ways. Sometimes they spread out like a wave, and other times they appear as tiny particles. It's as if something could be both a ripple in water and a stone at the same time. According to our everyday logic, this shouldn't be possible. But in the quantum world, it's perfectly normal. Even more fascinating is that an electron might not be in any single point at all. Until it's measured, it can exist in multiple states at once. In other words, we cannot say exactly where it is until we observe it. And this is where our minds protest, saying, "That's impossible." But experiments have been confirming the same thing for decades. Reality in the quantum world is not as simple as we think. There, probabilities become part of reality, and the rules of physics we know start to break down. To understand this strange quantum world, scientists conducted a very simple experiment with astonishing results. For the first time in 1801, the English physicist Thomas Young performed an experiment with light. Later, this experiment became known as one of the most famous and puzzling examples in quantum physics. It is called the double-slit experiment. The experiment itself is very simple. Imagine two very narrow slits in front of us, and light, or even electrons, are sent toward these slits. Behind them is a screen that shows where the particles land. Logically, we might expect the particles to pass through the slits and form two distinct marks on the screen. But the result was completely different. If we don't observe which slit the particles pass through, that is, if we don't check their path, they behave like waves. It's as if they go through both slits at the same time, creating a wave pattern on the screen. This shows that the particles don't just follow a single path, they move according to multiple possibilities at once. But here's where things get really strange. When we try to observe the particles, when we ask, "Which path did you take?" everything changes. Electrons no longer behave like waves, they act like ordinary particles passing through only one slit. Instead of a wave pattern, the screen now shows simple dots. In other words, just looking, measuring, or observing actually changes the outcome. This question blows the human mind. How can paying attention to something change its behavior? And this is exactly where the mystery of the quantum paradox begins. Now let's get to the heart of the matter. How does a quantum paradox affect the human mind? Quantum paradoxes are not just scientific curiosities, they are also mental challenges. From childhood, we've learned one thing. The world is stable, rules don't change, and every event has a clear cause. If something happens, it must happen for a reason. This way of thinking works in daily life and gives us a sense of security. But the quantum world turns this comforting system upside down. Here we are told that particles might not exist in a definite state until they are measured. reality, in a sense, may only take shape when we observe or measure it. This idea inevitably makes us think. If reality changes when we observe it, then we are not as detached or external as we like to believe. At this point, the human mind resists. Our brain says, this is impossible, because it challenges the very notion of cause and effect. Normally, an event happens first, and we observe it afterward. We are used to that. But in the quantum world, measurement can become part of the event itself. That's why quantum paradoxes feel unsettling, even a little frightening for many people. They force us to accept uncertainty. Probabilities replace certainty. Instead of thinking, it's either this or that, we must accept it could be both at once. And yet, this idea is also astonishing. It expands the boundaries of human thought. The quantum world shows us that the universe is far deeper, more complex, and more mysterious than our everyday logic suggests. Here, the human mind must either pause in confusion or reshape itself entirely. This is the true impact of a quantum paradox. One of the concepts that makes the quantum world even stranger is superposition. As we mentioned earlier, this idea says that a particle, like an electron or a photon, can exist in multiple states at the same time. In other words, you can't say an electron is simply here or there. Until it is measured, it can be both here and there at once. In our everyday lives, we never see anything like this. For us, an object is either on the table or it isn't. There's no in-between. But in the quantum world, these boundaries disappear. Here, reality isn't made of definite lines, it's made of probabilities. Another rule in quantum physics that really challenges the human mind is Heisenberg's uncertainty principle. This principle states that it's impossible to know both the exact position of a particle and how fast it is moving at the same time. The more precisely you measure one, the less certain the other becomes. And this isn't a limitation of our instruments. It's a fundamental rule of the universe. At this point, quantum mechanics sends us a very clear message. Particles are not in a definite state until they are observed. They exist in what is called superposition. That means they can exist in multiple places, in multiple states at the same time. An electron can be here and there simultaneously. It can spin in one direction and in the opposite direction at the same time, all at once. This idea is not just a mathematical game. It is a physical reality that has been proven repeatedly through real experiments. To understand it better, let's think of a simple example. Imagine throwing a ball. According to the laws of physics, the ball will either go to the right or to the left. There is no in-between. But in the quantum world, until you look at it, the ball seems to move in both directions at the same time. And the moment you look, when you observe, the quantum world is forced to make a decision. The ball can no longer remain between two possibilities. It goes either to the right or to the left. This is the most thought-provoking aspect of the quantum paradox. Reality seems to take shape through our observation. Now let's look at an even stranger concept. In the quantum world, it's called entanglement. Imagine taking two particles and linking them together in a special way. Once this happens, these two particles no longer behave as separate objects. They become, in a sense, a single system. And now comes the most astonishing part. The moment you measure one of these particles, the other one responds instantly. The distance between them doesn't matter at all. It could be 1 meter or millions, even billions of light years apart. The reaction is immediate. This idea was so strange that even Albert Einstein refused to accept it. He famously called it spooky action at a distance, and believed that quantum mechanics was incomplete. In his view, there had to be hidden rules, hidden variables that explain this behavior. But in the 1960s, physicist John Bell proposed a crucial theory on this very issue. This theory was later tested again and again through experiments, and the result was clear. Einstein was wrong in this case. Quantum entanglement is real, and it has been experimentally confirmed. What's even more fascinating is this. No signal is actually being sent between the two particles. One is not transmitting information to the other. Instead, they seem to be instantly aware of each other's state. This suggests that at a deeper level, the universe contains a non-local connection, a link that goes beyond our ordinary understanding of space. And everything we've talked about isn't just theory or philosophical speculation. These strange rules of the quantum world have already become real technologies and are beginning to affect our daily lives. In a sense, the paradox itself has become part of modern technology. The most famous example of this is quantum computers. Ordinary computers process information as either a 0 or a 1. Quantum computers, however, use superposition, working with quantum bits, or qubits, that can be both 0 and 1 at the same time. This makes them incredibly fast. For instance, in 2019, Google announced that their quantum computer performed a calculation in just a few minutes, a task that would take the most powerful classical supercomputers thousands of years. Quantum entanglement has also created a revolution in security. A technology called quantum cryptography is already being used in real communication networks. China, for example, is implementing quantum encryption via satellites. What's fascinating about these systems is that any attempt to eavesdrop or interfere is immediately detected. Simply interacting with the quantum system automatically changes it. Quantum technologies also hold great promise in medicine. In the future, quantum sensors could be far more precise than current MRI machines. They could directly and sensitively track the activity of neurons in the brain, which could lead to a much better understanding of neurological diseases. In addition, quantum simulations are helping scientists discover new drugs and develop new materials. They allow us to model the behavior of molecules and atoms with incredible precision, something that's practically impossible for classical computers. In other words, the quantum world that once puzzled the human mind and seemed paradoxical is now at the core of modern technology. These strange rules no longer just raise questions, they produce real, tangible results. Now, the biggest question is, if the quantum world is so strange, why don't we see any of these effects in our daily lives? The answer lies in a process called decoherence. Simply put, tiny particles can remain in superposition when isolated in a laboratory. An electron, for example, can exist both here and there at the same time. But large objects, like a soccer ball, are made of billions, even trillions of atoms. And this ball constantly interacts with its environment: air molecules, light, other objects. As a result, its quantum properties are lost in a trillionth of a second. In other words, quantum effects fade away for large, everyday objects. That's why we can't see superposition, entanglement, or other strange quantum paradoxes with the naked eye. But that doesn't mean they don't exist. The quantum world is everywhere, underlying everything. It's just that our everyday experience doesn't allow us to notice it. Every atom, every particle moves according to these strange rules, and the deep structure of the universe is shaped by these paradoxical principles. Quantum mechanics is still an unfinished theory. Scientists are still searching for answers. How can quantum mechanics and gravity be unified? What role does time play in quantum processes? Is there a connection between consciousness and quantum mechanics? Is a theory of everything even possible? Perhaps the next great discovery will answer these questions, or perhaps an entirely new form of physics will emerge, one that finally explains quantum paradoxes. Yes, the quantum paradox teaches us one important lesson. The universe is far stranger than we expect. And that strangeness is beautiful. Particles can exist everywhere at once. Observation changes reality. Information appears to travel faster than light. Particles pass through seemingly impossible barriers. All of this reminds us of one thing: never assume that we already understand everything. Reality is deeper, more mysterious, and more astonishing than we imagine. And that mystery is exactly what makes science so fascinating. Every answer gives rise to new questions. Every discovery opens the door to new secrets. The quantum world is waiting for us with its paradoxes, its mysteries, and its beauty. And perhaps the greatest paradox of all is this: the smallest things, atoms, electrons, photons, teach us the biggest lessons: to accept the unknown, to make peace with strangeness, and to never stop learning.